All right, here we go. This is the third video. We are still working on determining the solution set to rational equations and inequalities. And as I said at the beginning of the multiply divide one, we have to learn how to add, subtract, multiply, and divide these rational expressions before we're able to work on the solving. So we're building up to that. Video 4 will be about solving equations, and video 5 is going to be about solving the inequalities. So we're almost there. This is the last and major step towards that process. Here we go. So we have to identify our LCD, or our least common denominator. And to do that, we need to take a look at only the denominators. And then what does it mean to be the least common? It means to basically represent every factor, whether that factor is a number like 3 or 4, or that just a variable, maybe it's a squared variable, or it is an x minus 2, like a binomial factor, a polynomial factor. We have to represent everything in a way that it covers across the 2 or 3 pieces we're working with. So let me show you in some examples. Between this, for example A, between the 5p and the 4p, we have to represent the 5, we have to represent the 4. And that can only be done by a 20. And then we have to represent that there's a p in each of them. It does not mean that we need p squared, and we need the least common, and so 1p will represent the p in the denominator there. Let's take a look at the next one for part B. So part B, I have an 18 and a 9. Well, the 18 can already represent the 9. The 9 cannot represent the 18 because it's not large enough. So the number is going to be 18. In other words, what would clear the fraction? An 18 would clear both, a 9 would not clear both. And then I look at the variables. And in order to represent a cubed and a, I actually have to use the a cubed, because a would not represent all a cubes. So the a cubed must be used. And same thing for the b's. I need b squared. So my least common denominator is 18a cubed b squared. And you're saying, well, that's not the least. The least would be just choosing the a and the b. You're right, but the a and the b do not represent a cubed and b squared. So I actually have to use the largest number of exponents to represent what's in my denominator. Let's look at the next one. Here I have a 3 minus 4m and a 4m minus 3, and you think, well, those look very similar. And actually they do look very similar. They're opposites of each other. So in order to represent both of them, I'm going to use a -1, and then I'm going to use the 4m minus 3, because this right here is a -1 times 4m minus 3. So the 4m minus 3 is being represented, but the -1 takes care of the fact that the one of them is opposite. In the last one, I have an x squared minus 4 and an x plus 2. Well, x squared minus 4 is actually x plus 2 times x minus 2, which means that I need to represent an x plus 2 and I need to represent an x minus 2. So my least common denominator for these two is x plus 2 times x minus 2. In example E, our last example here, I must factor both denominators. So this factors to x plus 2 and x plus 1. The last one factors to x plus 2 and x plus 3. So I will have to represent the x plus 2 that shows in both. I will have to represent the x plus 1 and the x plus 3. So my least common denominator has all three of these. I do not have to duplicate the x plus 2, because if I'm just talking about representing everything, I've done that. Now we actually get to add or subtract, because the first part of adding and subtracting is to get common denominators and to adjust your fractions according to the changes that you've made in your denominator. So the first thing I'm going to do here is identify my common denominator between 9x squared and 6x. And the first thing that comes to mind for me is 18, because the 18 will accommodate the 9, and the 6 is also accommodated there. So I have an 18, and then I need the x squared. So I'm going to put a plus sign, and I actually only have one fraction because the goal is to make this one fraction. And I think about how I changed the 9x squared to turn into 18x squared, and that is that I doubled. I doubled it. So this is now a 10. And then I think, how did I change the 6x to become an 18x squared? How does 6x go to 18x squared? It's because I multiplied it by 3x. So I have to multiply the numerator also by 3x, and 1 times 3x is just 3x. I can simplify this if it bothers you that the 3x and the 10 are, not in the standard form direction, but actually this is in the most simple reduced form. Let's take a look at the next one. The next one has a y minus 2 and a 2 minus y. And just in the previous examples when we were doing the least common denominator, this is actually just an opposite problem. So it's just a negative 1 times the y minus 2. So if that's the case, then my denominator is a negative 1 times a y minus 2. That makes this second piece not actually have to change at all because it had everything that the common denominator has. So it is unchanged and the 8 remains. This one, however, needs to be multiplied by a negative 1. So I get a negative y plus 8. The negatives do not cancel because this negative is actually on just the y. It's not on the entire fraction, or the entire numerator. So these negatives do not cancel. And this is the simplest form. And let's take a look at the subtraction problem. We'll start by factoring the denominator so that we can determine the least common denominator. This factors to x plus 2 and x minus 1, and the second one factors to x plus 2 and x minus 4, which makes my least common denominator, I need an x plus 2, I need an x minus 1, and I need an x minus 4, and everything has been represented. The numerators need to be adjusted because my denominator of my first fraction only had these two pieces, so it needed to be multiplied by x minus 4. So that leaves me 3x minus 12. The second one got adjusted because there's a factor of x minus 1 now. So I'm going to write that. However, this is so important. I am subtracting. Which means that I'm not distributing a 1 onto this quantity. I am distributing a negative 1, which means the parentheses are so important. And if you forget them, this will be incorrect. So I'm going to distribute and get a negative x plus 1. Negative x plus 1. And I can combine like terms to have a 2x minus 11 over the three quantities of x plus 2, x minus 1, and x minus 4. This cannot be reduced anymore, and that is the final result.